Good afternoon and greetings from Indian Institute of Remote Sensing. So today we will be talking about remote sensing and GIS applications for disaster management and mitigation. Mainly, I will be dwelling on the challenges and the opportunities in this particular domain. So if we see what are the or what do we understand by natural disasters? See, disaster is any event is considered a natural disaster only if it affects the human population or human society and the various components of the society, like your food security, water security, your dwellings, infrastructure, communication, economy, your health, or even your ecosystem services. If they are affected, then any event can be termed as a natural disaster. So just to give you a background, I'll just try to pictorially elaborate some of the very commonly used terminologies which are there in natural disasters like hazard, exposure, risk, and vulnerability. So hazard is any disruption or loss due to the unexpected event, whereas the exposure is the component of the society which is affected because of this unexpected event. Vulnerability is basically the ability or the inability of a society to resist or overcome the impact of the hazard. And risk is a subset of all these three. So if we talk about disaster management and risk, it is basically focused on the community. So just to give you some more background about the disaster management uh, and the global commitment towards overcoming the impact of disaster management is basically enshrined in some of the frameworks which has been carried out, which started with the Oklahoma Principle, then Hugo Framework of Action, and now the Sendai Framework. So Sendai Framework was adopted as part of the Sendai Conference in 2015, and it aimed to achieve a substantial reduction of disaster risk and losses in lives and livelihood, with the goals to prevent new and reduce existing disaster risk through implementation of various strategies which are there. You can read through in the paper in this. So the Sendai framework for the first time identified 7 targets of action. That is to reduce the mortality, to reduce the number of people affected, to reduce the economic loss, and to reduce the damage to critical infrastructure and services by 2030. And how to do it? Through by improving the disaster risk reduction strategies, improving the early warning, and improving and decreasing the number of lives lost. So to achieve these 7 targets, they identified 4 priorities of action. That is basically understanding the disaster risk, investing in disaster risk reduction for resilience, strengthening disaster risk governance to manage disaster risk, and enhancing disaster preparedness so that effective response and recovery, rehabilitation, and reconstruction can be carried out. So in principle, ISRO basically supports a disaster management activities by providing inputs. So ISRO has a dedicated institutional mechanism wherein disaster management decision support center is at NRSC, which are in association with nodal agencies like Ministry of Home Affairs, Prime Minister's Office, Cabinet Secretariat, NDMA, NIDM, and state agencies, as well as some of the NGOs who are working in this field. And what does it do? It monitors and does a damage assessment of natural disasters, mainly flood, fire, earthquakes, landslides, to some extent cyclones. Then it also maintains a national database for emergency management. In case of emergencies wherein the terrestrial communication network is not available, it provides VSAT-based or satellite-based virtual private network for communication. It is also working on strengthening various early warning systems by integrating space technology with a number of other inputs like models. And it is also involved in development a network of various ground-based sensors like hydromet and other sensors. So some of the key aspects wherein we are working on are the developmental efforts through SAR and other things. Then the support to IoTs and constellation of EO satellites. Then we are also providing a constellation or working on constellation of Earth observation satellites for providing the inputs. We are working on various R&D areas also like landslides, earthquake precursor studies, extreme weather events, and forest fires. And we are also providing international commitments through International Charter on Space and Major Disaster, UN SPIDER, Sentinel Asia, and others. So where does space technology fit in the disaster management framework? Basically, space technology provides us information for decision makers through observation, or I would say temporal observation, which generates the information. Apart from that, we also provide satellite-based location services through our satellites like IRSS, and in case of emergency, we provide satellite-based communication. So in all the aspects of disaster cycle, right from the event, relief, rehabilitation, reconstruction, mitigation, and preparedness, satellite technology or space-based technology provides us critical inputs in the various aspects of disaster management. So when we talk about natural disasters in India, India is vulnerable to a wide range of natural hazards, particularly flooding, cyclones, drought, extreme heat waves, landslide, wildfire, and earthquakes. I doubt that there is any disaster which doesn't happen in India, except perhaps a volcano. Although India does have a active volcano, but since it is in a place which is uninhabited, so it doesn't fall under the category of natural disaster in India. And a number of studies have actually shown that because of the climate change, the intensity, duration, and frequency of weather-related events are likely to increase. And most of the disasters which are prevalent in India are actually climate driven. Say for floods, your cyclones, then heat waves, they're all the intensity and frequency is likely to increase because of the climate change. So what does geospatial technology provide us? It provides us temporal observation and patterns through satellite data, which helps in generating scientific understanding in form of maps. Now, when all these maps are overlaid or can be overlaid in a GIS domain and are able to talk to each other, we can develop various models and forecasting, as well as understand the processes involved in various uh, uh, events, which we classify as natural disasters. And this helps us in forecasting or developing an early warning systems for various disasters. So let us start with some of the commonly known disasters and how space technology play a role in their monitoring, as well as providing some level of forewarning or risk analysis. So when we talk about geological disaster, one of the most spectacular disaster which comes to our mind is earthquake. So here, when there is an earthquake, what happens? There is some deformation on the ground. So this deformation can be observed in form of either subsidence or upliftment. And interferometric SAR has been used extensively for detection of these particular features. Apart from that, we are also able to map the geomorphic elements, which are basically the scars of previous earthquakes. In many of the cases, earthquake also provides or produces thermal anomaly because of disturbances in the subterranean water systems and their proximity to the magmatic material there. This results in thermal anomaly, which has been very extensively documented in many of the earthquakes, including the Turkish earthquake, which happened a couple of years back. Now there are some, although there is no direct, I would say, model which can forewarn or predict an earthquake, because the complexity of the process is still not very well understood by science. However, the reason of the earthquakes, that is the global plate motions, these global plate motions can be detected very well using satellite-based global navigation satellite systems, which a specialized form of which are the continuously operating reference station, which are nothing but a very high resolution GPS fixed to a particular location, and its movement with respect to other continuously operating reference stations gives us an idea about the movement of the various plates, continental plates in time. Apart from that, there are some other what we call experimental studies which are going on, like the anomaly in the total electron content in the ionosphere. It has been observed that a few hours to around 14 days before an earthquake, there have been reports of thermal anomaly, which we have still not been able to scientifically tell what may be the reason. But it has been observed, and these may be some of the precursors which are being studied to somewhat provide forewarning or risk analysis of the earthquakes. Another aspect is the landslide. The scars of the landslides are very easily detected from satellite data using pre and a post event data sets. However, using a combination of various geomorphic elements, a team at ISRO has been able to model the risk or the hazard map of the landslide prone area. And these maps have been developed for the Char Dham route of Uttarakhand and is extensively being used for locating the earth movers in case there is a earth landslide. Recent studies in advanced interferometric SAR like SBAS or INSAR are able to provide the land surface movement, which has been very well observed in the Joshimath event a couple of years back. So we have been able to use the interferometric SAR. It's called PS INSAR or persistent scatter interferometric SAR, which uses a number of satellite data to develop interferograms, and based on a certain reference timeline, we are able to track the subsidence or movement of a slope and the rate of movement of the slope. So you can see in the figure on the left, when we have compared it with the continuously operating reference station located at Joshimath, which is basically operated by Survey of India, we have been able to have a very high correlation of the ground movement or the ground subsidence in the area, which had taken place during December and January of 2022 and January of 2023. Another aspect of disaster which is extensively studied using satellite data are the hydrometeorological disasters, mainly floods. Anyway, using various satellite data, we are able to observe the inundation, the temporal duration of the inundation, even when there are clouds using these radar data. But the more interesting part is the development of early warning system for flood. So presently we have been able to have a fairly good early warning system for the floods, especially in the Brahmaputra basin, the Godavari basin and Tapi basin, and its work is being done for the other basins in the country. So what it does, it basically uses the inputs of the rainfall in a particular region. The inputs can be through a model, through the rain gauges, and through the Doppler radars. So once you have the rainfall, amount of rainfall in a particular area, we can use various softwares like Mike or Across or HMS to develop the discharge in a particular area. Once we have a discharge in the discharge, then from that we can generate water profiles, and the water profiles can be used to develop the inundation in a floodplain. So now what we have done is that we have generated almost more than 5,000 simulations of different scenarios, and now these simulations are kept in a library, pre-computed flood map library. So now moment we have the data from the WRF as well as radar and the actual rainfall through the rain gauges, the appropriate library, the flood map is taken out from the library and the information is transmitted to the ground where the evacuations are carried out. So you can just recall that previously we used to hear a lot of lives being lost or damages because of flood, especially in the Mahanadi region. But now, because of these effective early warning systems, most of the damages to the infrastructure or losses to the lives are reduced because of this input. Now, this sort of floods may not be just because of rainfall. Sometimes this can be because of many other events, like what we had in the Chamoli district in 2021, wherein a rockfall induced a flash flood in Chamoli and devastated the upper reaches of the Rishiganga basin up to almost Joshimath. So what happened basically was a big chunk of rock fell around 2 kilometers into the valley floor, wherein it created a huge amount of energy on impact. And this energy basically melted all the permafrost which was there, along with the snow which had accumulated, and this entire thing just rushed downhill. It was a steep slope, and in the lower reaches, there was one hydropower site which was being constructed. That was a Tapovan hydropower site, and it was totally devastated. And on more than 250 people who were working in that particular site have been missing. Another of the classic example is the Kedarnath flash flood, which is again what we call not a simple rainfall event, but a combination of events which led to it. So what had happened was that during the 15th to 17th of June in 2013, there was a meteorological condition over the region, and there was heavy rain over Chorabari and Companion Glacier for almost 2 days, which basically washed down all the debris and the ice into the Chorabari Lake, which was basically a moraine dam lake. So on the night of June 17th, this dam broke, and the Kedarnath town, which was just a few kilometers downstream, was totally devastated. And you also know about the other damages which happened subsequently. So using remote sensing, we were able to determine the damages to the building. But more than that, we could generate a digital fly-through of the rescue team had a good what do you call premonition of what to expect in that region. Another of the hydrometeorological disaster, though not very spectacular in its appearance, but still plays a very important role in the economy of a country, is a drought. Here also, remote sensing plays a very important role in identification of the drought conditions, mainly the meteorological and agricultural drought, wherein the decrease in the rainfall as well as inadequate soil moisture can be detected, and using this information, the early warning and risk analysis model has been developed and is presently been transferred to the Ministry of Agriculture, wherein this information is provided to the farmers, like the area specific vulnerability, the price trend of food and feed, and the drought early warning, mainly the time of occurrence, the spatial extent, duration and severity of the drought. Then we come to the coastal disasters like tsunami. So Earth observation can provide very accurate estimation about the damage of because of tsunami. But one aspect which has played a very important role in tsunami, that is the tsunami early warning system. So how does it work? Tsunami early warning system is basically, it constitutes a network of pressure sensors which are established in all the ridges under the Bay of Bengal. And all these pressure sensors are connected to GPS buoys, which are in turn connected through a satellite communication satellite to center which is dedicated for tsunami early warning system, that is INCOIS in Hyderabad. Now, moment there is any there is any earthquake in under the sea, these pressure sensors are activated, and the information is sent to INCOIS within a fraction of a second. Now, INCOIS has also run more than 90,000 simulations of various intensities and locations of these particular earthquakes, and have developed more than 90,000 scenarios for the tsunamis. So they're all models. So moment the information goes, the software basically picks out the most suitable simulation from the library, and the coastal population is informed about the intending tsunami. It's basically 2 to 5 minutes the coastal communities are informed through various sources like mobiles, radios, televisions, and loudspeakers. So now we will not be seeing a repeat of what happened in 2024, wherein people even did not know what tsunami is. So now we are more aware of the tsunamis. Another aspect of coastal disasters are the sea level rise or storm surges. Now, because of various things like climate change, global warming, their sea level rise is there. And sea level rise basically, apart from inundating the coastal areas, are also responsible for infiltrating into the coastal aquifers. So moment the coastal aquifers is infiltrated by the seawater, your access to fresh water is lost. So you will not be having drinking water or fresh water for your normal consumption. So that is one of the biggest issues of sea level rise, apart from the inundations. Another area of coastal disasters where Earth observation plays a very important role are cyclones and are extensively used for observation and monitoring. Now we are in a situation wherein we are able to detect even the cyclogenesis, that is the formation of a cyclone. We are able to predict the path or the track of the cyclone, and we are now in a position to even predict the wind speed and the associated rainfall because of the cyclone. In fact, what we can say that the recent cyclones, which were of very high intensity, didn't result in any single death compared to the Orissa super cyclone, which was of a similar intensity where more than 10,000 people lost their lives. So this is what the Earth observation provides us, or space technology provides us. Apart from that, in future, we are going to face this particular disaster a lot, that is the heat wave. Here also, space technology has helped us in understanding how the heat wave is distributed across the country, which include the combined heat wave index, heat wave hazards, to develop the heat wave risk, basically with respect to the population. Apart from that, the impact on human health, disease and surveillance, and disease surveillance can be carried out through geospatial technology. Especially, we have been able to track the COVID-19 growth across the country during the COVID period. Now we come to the environmental disaster. Among the environmental disaster, one of the most spectacular environmental disaster is the forest fires. So now the forest fires can be observed from space very easily. And this is basically a digital fly through of the fire affected regions over Uttarakhand in 2019. You can see very clearly see the areas where the fires are actively burning. But it's not just that, we have also been able to detect or automate the burnt area or fire affected area through various advanced technique. But it's not just the observation or monitoring. We are now also in a position where we are able to tell about the forest fire risk in a particular area. See, we cannot predict fire very with a high surety, because most of the fires in India have some or other anthropogenic origin. Though they are mostly accidental, but it needs some human activities to start the ignition of that. But what we can do is that we can identify the areas which are at risk, wherein we use the fire weather and the conditions at the ground like fuel, topography and soil conditions. wherein we have developed a forest fire risk index, which has an accuracy of ranging between 86 to 92%, because this is calculated daily. And this has been, the accuracy has been established with respect to the actual fire occurrences. We also have developed a fire spread model, which uses the fuel availability, meteorological conditions, the connectivity among the patches, and cellular automata to develop the fire spread over a particular area. So this is an example of a fire spread modeling which has been carried out in Corbett Tiger Reserve, wherein over 24 hours we have shown how the fire has actually spread. And this is the accuracy assessment with respect to the actual burnt area, wherein the black patches, which has been the actual burnt area, has been overlaid over the simulated burnt area, and the black patches are the areas where the fire has not burned. The red are the area where the patches have actually burned. Other aspects of environmental disasters like atmospheric pollution, what you find now in Delhi, and dust storms are there. So I'll just like to take a few minutes to tell you about the atmospheric pollution, mostly in the Indo-Gangetic plains and over the northern Indo-Gangetic region, especially over Delhi. So it's basically this is the phenomena which is because of various global wind patterns. So during this time of the year, the wind actually blows from south towards or southwest to northeast because of the Coriolis effect. So once this happens, these winds basically pick up the dust from the deserts between Pakistan, Afghanistan, and Iran, and these are carried by these winds towards the Hindu-Kush Himalaya. Now, because of the Hindu-Kush Himalaya, these winds turn towards the Punjab plains, and they move towards Haryana and Delhi, as well as western Uttar Pradesh. Incidentally, it is during this time we also have the farm fires, and there is another phenomena which happens, that is the thermal inversion, wherein the dusts are not able to dissipate. Because of these conditions, there is a very bad situation in this particular region, wherein you have a lot of aerosol content in the atmosphere. Now we come to some of the natural disasters because of climate change, like glacial retreat or glacial surge. So most of the glaciers in the Himalaya, they are retreating, which indicate that there is going to be a dearth in the glacial or the availability of water in this particular region. There are other aspects like surging glaciers, wherein because of the less friction in the base of the glacier, some of the glaciers are surging ahead. These are also because of or some of the impacts of climate change. But most disturbing are the glacial lakes which are being formed. There are some glacial lakes which have basically formed the supraglacial lakes, like one of the glacial lakes in the eastern Nepal. So this glacial lakes has since 1960 is expanding and now has increased to around 2.5 kilometers in length and has an area of around 1.44 square kilometers. Is basically the Imja group of glaciers near Mount Everest. And this glacial lake is around 150 meters deep in some places, and is basically a very high risk of glacial lake outburst flood. There are other aspects of natural disaster due to climate change. One thing which I would like to bring to your mind is like large scale singular events. See, the weather of a region is basically determined by the ocean currents, the warm currents and the cold currents. And these all currents, these ocean currents are basically like moving around like a conveyor belt, which we call as a great ocean conveyor belt. I'll just take an example of one of the ocean currents, that is this current, which is known as the Gulf Stream, which basically turns or which moves between Gulf of Mexico in the west to north of Europe or the Arctic Ocean across the Atlantic. So this is a warm current known as Gulf Stream. So when it reaches the North Arctic region, the cold water from the Arctic basically cools this warm currents, and the change in the thermohaline condition, due to which the water become dense and they go down. So just to give you an analogy of the amount of water which basically flows in this ocean current. So the Gulf Stream, the amount of water which goes down because of cooling north of Europe of the Gulf Stream, the amount of water which goes down in 1 hour is more than all the terrestrial fresh water which is available. So it is projected that the northern hemisphere sea ice may almost disappear by 2100 because of the climate change. Now, if this happens, the warm Gulf Stream might not get cooled when it reaches north, and then it might, and there will be no change in the thermohaline condition. So this entire ocean conveyor belt might stop. Once it stops, you can imagine what happens. See, if you take the example of north of Europe and the Greenland, they are almost at the same latitudes. Whereas Greenland is perpetually covered by ice, the Europe is more or less ice free. This can result in a huge impact on the food security over the world, because then most of the northern Europe will be covered by ice. Now, apart from Earth observation, the satellite-based navigation or IRNSS, which provides us the location-based services, also provides us the facility for emergency communication. So this came around after the cyclone Oki killed around 70 fishermen in Kerala. So what happened was that the fishermen had gone out to the sea, and then the cyclone, which was earlier south of Sri Lanka, suddenly veered towards north, and the fishermen who had gone out to the sea could not be informed. Because what happens is that our mobile phones or the GPRS stops working 5 kilometers inside the from the coast. So ISRO basically developed a device which can be connected to the mobiles through Bluetooth, and it provides us the ability to communicate through text messages through the IRNSS satellite systems, both inbound and outbound. So now they are used to warn the fishermen, and the fishermen can also send SOS. Apart from that, these are also being used to provide what we call provide the information to the fishermen about the boundaries or the maritime boundaries. Whenever a fisherman is crossing into another country's maritime boundaries, they are being warned that they are crossing into either Sri Lanka or Pakistani waters, so that the people are not inconvenienced. Apart from that, during disasters, we are helping in providing communication network through satellite-based virtual private communication network, which consists of one hub at Ministry of Home Affairs in New Delhi, which is the primary node, and the user nodes are spread all over the country. So each district has basically 5 to 6 satellite-based phones for emergency communication, and they provide the communication through uh, voice, video, and data. Apart from that, very recently we are also using crowdsourcing for various aspects of disaster management, especially for the Chennai floods and the Kedarnath flood. Facebook was extensively used to divert or reroute the evacuation and the relief for the critical areas. So when we talk about ISRO's Earth observation based disaster management support, we provide support for monitoring, for floods, cyclones, forest fire response and assessment, and Uttarakhand and landslides during monsoon, especially in the hill states. If we talk about alerts and forewarning, so we have the flood early warning system, landslide early warning system, forest fire risk index, which actually help in providing the alerts. And we also provide geoportals. So we have the NDEM, that is National Database for Emergency Management. Then we have a Northeastern Regional Node for Disaster Risk Reduction and Meteorological and Oceanographic Satellite Data Archival Center. And we are also carrying out various advanced research like long-term fire studies in Hindu Kush or advanced in-service techniques for land deformation or spatial heat wave hazard modeling. There are many areas where people are working, which includes lightning and extreme rainfall events. So what are the gaps in the research, especially in the disaster risk reduction? They are basically in the areas of early warning systems and early detection, interaction of climate and disasters, specifically with respect to domino effects, development versus disasters, comprehensive risk assessment, and technological integration for space-based disaster management support, which can include satellite-based or satellite-enabled IoT and other aspects of AI or machine learning, even big data analytics to develop decision support systems. So how are we going to go forward? We need to integrate AI, ML, and big data analytics big time into disaster risk reduction, wherein cloud computing, edge computing, digital twin, and deep learning can be used through the upcoming technologies like 5G, 6G, edge connectivity, and complementary fiber network and cell towers for real-time data integration and processing, effective early warning systems, sustainable resource utilization, and conservation and protection of ecosystem services. So what do we need? We need seamless data from variety of sources. We need advanced data processing algorithms, develop various methodologies, tools and models, improve the computer infrastructures, and have number of experts and decision makers who are trained in these areas. So basically what we need is an integration of technologies, not just from space-based, but also from ground-based and other related technologies, so that we can have an integrated suite of applications convert the data to knowledge for effectively supporting disaster risk reduction and saving lives. So these are some of the areas or the screenshots of the various support provided by the National Database on Emergency Management and its ability. Before I call it a day, I'll also like to tell you about the International Charter on Space and Major Disaster, which is an international mechanism providing space-based information for disaster response, wherein we are the founder member and have till date provided support to thousands of people across the globe. So when we talk about the challenges and opportunities in this particular area, what we need to do is reduce the loss of life and property due to natural disaster, develop effective mitigation approaches, spatial decision support system. So how do we do it? There are three areas. One is effective early warning systems, where we need to understand the disasters, develop accurate model and novel approach. We need to have a disaster risk governance through information generation and information dissemination, and disaster resilience and build back better through community awareness, resilience, and disaster resilience infrastructure. Thank you very much. So if there are questions, we will have them after a few minutes. Thank you. the first question, how does GIS help in forest fire mitigation? So see, if we talk about forest fire, the remote sensing, and I would talk not just GIS but remote sensing and GIS. So remote sensing and GIS can play a role in almost all the aspects of forest fire mitigation, be it active fire locations, be it the burnt area estimation, be it fire spread. All these can be identified using remote sensing and GIS. For example, the thermal data which thermal sensors which are there in the satellite is able to detect the active fire locations, which is provided globally every on a daily basis. If we talk about the burnt area, so using the shortwave infrared region of the multispectral satellite data, we are able to detect the burnt area almost once every 7 to 8 days globally. And with the advent of the various high resolution multispectral satellite data provided by private sector constellation, we are now in a position to get this information even on a daily basis. If we talk about the forest fire risk, so there are various ways to retrieve using satellite data the weather parameters of a particular area, as well as the situation in the ground, wherein we are able to tell what is going to be the situation in the next 24 hours. For the spread, so once a fire has occurred, how is going to spread over a landscape? Again, various GIS-based models, which include WRF, which include graph theory, which include the what we call as cellular automata. We are able to provide information on an hourly basis how the forest fire and the rate and the direction in which the forest fire is going to spread over the next 24 hours. So GIS helps in forest fire mitigation in a lot of ways, and it's basically being used in the ground by Forest Survey of India and the various forest departments across the country. So second question is how GIS and RS provides early warning for cyclone, drought, and flood. See, for cyclone, we have our INSAT series of satellite, which is able to detect the cloud top temperature, and also it's able to map the cyclone formation as well as map its movement across the seas and oceans. If we talk about droughts, yes, there are various numerical weather prediction models which provide us information on the weather parameters, especially the rainfall and how the rainfall is going to be over the next few weeks or months, which can provide us an information about the impending drought-like situation across the landscape. And for the floods, as we have already discussed in the talk, there are a number of models which are able to provide us the rainfall over a particular region. Now, when we have this information of the rainfall using various hydrological models, we are able to model the discharge. And with the discharge, we are able to model the water profile and also the water spread over a particular region. Now, if you can develop various scenarios, thousands of scenarios of the various types and durations of the rainfall, you can very easily create simulated models or simulated model outputs of the potential inundation in various areas. And these can be used very effectively as a flood early warning systems. But remote sensing is still not able to predict earthquake. That is there. So we are not in a position to use remote sensing for predicting earthquake. Although we can identify the areas which are undergoing a considerable amount of strain through the network of continuously operating reference stations, but this is not enough to predict earthquake. So I hope I have been able to answer this your queries to your satisfaction. So if there are no more questions, we can close this session. Thank you very much and best wishes from IIRS. Thank you.
Okay, thank you, sir.